Find all zeros, both real and imaginary, of the following polynomials. F of x equals 2x cubed plus 9x squared minus 2x plus 15. Okay, so when we approach a cubic or higher polynomial and we want to find all the zeros, first thing we need to do is get initial rational zeros. And initial rational zeros will be found by using the calculator. And on the calculator, what we will do is graph it, because any place where we have an x-intercept is a zero of the polynomial. So 2x cubed plus 9x squared minus 2x plus 15. If I graph this, it doesn't look like I get much information, but I certainly can see one place where this function is crossing the x-axis. And that's at -5, it looks like. Let's see, 1, 2, 3, 4, 5. Yep. All right, so that's all I really need. It's just one initial zero, because if I factor that out using synthetic division, the result is going to be a quadratic. And quadratics I can handle using other methods. I don't need special use of graphing and that sort of thing. So bring the 2 down. 2 times -5 is -10. That adds up to -1. -5 times -1 is 5. This adds to 3. 3 times -5 is -15, and the result is 0 for the remainder. Now, these coefficients make up a quadratic, which look like 2x squared minus x plus 3 equals 0. And this is not going to factor, because if it were going to factor, we would have come up with those zeros on the graph. So we're going to need to use completing the square or quadratic formula, something of that nature. Now, normally I would choose completing the square, but in this case, if I go through the steps of completing the square, I'm going to have to divide through by this 2, which is going to give me some fractions to work with, and the process just gets more and more difficult from there. So in this case, I will use the quadratic formula. So the quadratic formula, of course, is x equals, well, let me write it to the side, -b plus or minus the square root of b squared minus 4ac all over 2a. So -b is going to be the opposite of -1, which will become +1. b squared would be 1 as well. 4 times a times c, so 4 times 2 is 8. 8 times 3 is 24. And that's all over 2 times a, which is 2 times 2, or 4. So I have 1 plus or minus the square root of -23 divided by 4, which is 1 plus or minus I times the square root of 23 all over 4. And those are my remaining zeros.